Thank you very much. Thank you, organizer. Thank you, organizer. Thank you, session chair. Thank you, all attendees. I'm very proud to present today's technical sessions, which I will discuss today about sustainable building construction and carbon emission for structure. At the beginning, I would like to introduce my team, my research team. So my name is Saidur Chowdhury. I am basically an environmental engineer. And Danish and Samar is like a structure engineer. Their expertise in wind engineering and also earthquake engineering. And Dr. Andy is wood engineer. So he did his PhD in wood engineering, I think in Colorado. And Dr. Tahar is like methane engineer. So we all together trying to solve one of the very important issues, which is carbon emission for construction project. So today discussion is very straightforward. I will discuss about carbon emissions and climate change and sustainable energy materials in the introduction section. And then I will discuss about scope of the study, very straightforward. Two things, which is we will measure some structural performance and we will measure the carbon emission from structural frames. And then methodology will be same. We will evaluate how to structure performance and how to the structure frames perform, and then carbon emission using some software tips and some analytical calculation. A results discussion will be presenting some graphs, some calculation results, and then finally I conclude the presentation. Okay, so let's discuss about what is carbon footprint. Carbon footprint is the total amount of greenhouse gas emitted to the atmosphere that includes also carbon dioxide and methane. And those greenhouse gas, which is carbon dioxide, methane, they stay in the troposphere. And then when long wave radiation will interact with these layers, which is composed of all greenhouse gases, they produce lot of thermal energy. And this thermal energy, creates some radiative forcing. And this radiative forcing to change the climate. And due to climate change, what is the consequences? Very bad. Sea level rise and natural calamity, extreme weathers, droughts, and what's this called? Those melting of snow glaciers, right? So this is the consequence of climate change. Look at this picture shows the carbon dioxide contribution from what construction project and operational period. And the left side shows the global greenhouse gas emission. Okay. Here the carbon dioxide contribution from different engineering materials. And if you check it, you see the timber contribution is compared to other timber contribution very less. So we try to introduce timber in construction project, and this discussion will be, we think, timber will be sustainable materials. We'll verify. Okay. So here we propose two types of timber. It's glue-lam, which is glue laminated timber, is a beam-shaped lamination of wood that are bonded together with some moisture-resistant adhesive, and it could be curved, it could be straight, and those they're bonding parallel with the length of the wood structures. So they could be used for beam structures. But if you're going to see cross-laminated timber, this is a plate form. This cross-laminated timber will be glued together the crosswise and bonded in the form which could be we can use for roof slabs and walls construction product. Okay, so this is the glue laminated and cross laminated timber. So we are trying to propose this glue laminated timber in construction project. So look at these two types of glue laminated and CLT, which is cross laminated timber pictures. Okay. So now let's discuss about scope of work. So scope of work in this study is very straightforward. We will evaluate the structural behavior, and then we will calculate the carbon footprint, which means we are measuring the carbon dioxide emission from this kind of frame structures. So three types of frame structure we propose. One is cross-laminated timber, only cross-laminated timber. Another is reinforced concrete and steel. Another is hybrid together. Cross-laminated plus concrete steel together. Okay. So here is the structural figures, two figures, one with the wood structure, one with concrete structures. So we're discussing on frame. So here, so these sustainable materials, the purpose of this study, to propose these things in our mega project. The mega project NEOM built based on what? On based on principles of renewable energy and sustainable materials, zero waste concept, zero emissions. So those materials we'll check if these materials could fulfill this purpose or not. There is only one. There is another project in NEOM and other projects also. Actually, we have mega project. Okay. So moving to the methodology section. Methodology section, we use ETEPs to model to shape some mid-rise buildings, 10-story buildings, and one building we propose with CLT only. One building we propose with the carbon and one building with the concrete and steel together. Another is hybrid together, which is CLT and concrete steel together. So we are not proposing in this study steel structure separately, but still we come with the concrete structure. So using this ETEP, this is the the volume of the three type of buildings. This is frame 1 CLT, frame B steel concrete, and frame C will be steel concrete and CLT. So now we use ETEP to measure the total weight of this frame A, frame B, and frame C. This is very helpful to calculate our carbon emissions. And you see this frame A, which is very important study, which is column, beam, wall, floor, everything we measured using the ETEP. We modeled it, and then we found the total mass of these buildings. Okay. So then we try to, we have different experimental results, but I will present you on the one result, which is very important, which is the story drift in X directions due to wind and earthquake. And deflection shows, acceptable result according to the Saudi building code. Look at this building A, which is CLT, little bit higher, but still, within the building codes. According to the building codes, it's like 25% less, right? And sorry, not 2.5% less deflections. And also, those hybrid, present very well. But three are accepted results according to the Saudi building code. So now, after those structural stability analysis characteristics, we try to check carbon emission. So this is the three equations, very straightforward equation, analytic equation we use to calculate carbon and carbon dioxide emissions from three structural frames, which is building A, CLT, building B will be concrete and steel together, and building C will be hybrid, which is CLT and then concrete together. So here we use air fraction. Air fraction is a very important term to calculate carbon emission, carbon dioxide in atmosphere. Air fraction means carbon dioxide remain in the atmosphere divided by its total amount of carbon dioxide generated from our activities. So we use these principles, these three equations, to calculate our carbon emissions. Here is the results. You see, in CLT building, huge amount of storage stored in the carbon. Sink means it's stored instead of emission. Those CLT buildings store carbon dioxide carbons. And then building B produce, see the production, P means production. And building C, which is CLT, also performing well, store carbon dioxide. So we can propose building C and building A for our future mega city, which is kingdoms visions. And then during the calculation, we use some unit amount of carbon dioxide production. So in case of I think 410 kilogram carbon dioxide emission per meter cube of concrete, and then we use 676 storage of carbon dioxide in that timber body per meter cube of CLT. So like that. So here is like result shows straightforward column. CLT A building and then C building, which is hybrid building, is we can propose for our project. Again, back to the carbon, NEOM city. NEOM city concept is what? NEOM city concept is zero emission, right? So our study will be very helpful for the future megacity. So we are thinking about our application of this wood uses as building materials in construction project, but there is some effects if you don't make a good policy. So look at the high consumption of wood not only in construction but also in future packaging and energy production. So how we can recover this kind of wood shortage or green areas damages. So we can create some policies for reforestation and replacement of green areas to control, to preserve the ecological balance and green space. So if you implement these two things before going for using the wood in mass scale, we can prevent our regional weather or regional climate. So now carbon footprint production or reduction from construction work, we have to follow some steps to implement in a planned way, which is we have to use the recycling, concrete, brick, steel, wood, mortar in the building construction. And when we use renewable energy during the material manufacturing process, reduce construction waste and demolition. And number 4 will be reduce transport and shipping. So if you build our industry in the local area, we can reduce those carbon emission from reduced transportation and shipping steps. And then we have to check our sustainable materials. In this case, our results supported, right? So can you propose CLT or hybrid engineering materials for any mega project, which vision will be based on renewable energy, zero waste, zero carbon emissions. Okay. So these activities will be empowered, or to a target which is climate change, production of climate change. So look at this. We have to when you generated, for example, construction demolition, we have to check very carefully. So we study, always research, doing some research to find out this 100% uses of this wastes. This waste, which is in this studies, construction demolition waste, will be applied to different activities, and then other waste will be used for production process. For example, methane production was for fuel, or and then also you can produce some biodiesel for transportation purposes. So all those activities can reduce carbon emission. Also, we can, if we use those methane, which is generated from waste, we can produce a green electricity, and then we can drive green car if you use the alternative fuels. So this way we can empower in direction to climate change. So now the conclusion will be straightforward. We can propose, or Kingdom can easily achieve that the target of zero carbon emissions from building construction. Engineers shall, with no doubt, reconsider this incorporation of CLT composition within the mid-rise buildings due to their lightweight and carbon sinks features. Again, in addition to these discussions, the CLT building has some advantages compared to concrete. Number one is what? It's sustainable, because instead of emission, it can store carbon dioxide. And then those CLT materials will be easily produced using some less water or available technology, renewable technology. We can build those CLT materials. It's the structural capability. Structural capability, we checked it in our study. It's like comparable to cement and concrete. So comparable to concrete and those steel structures. So we can propose CLT type buildings in our project. And number 3 is that we can save our time because it can easily fit in. It is lightweight, right? So we can easily, in a short period of time, we can construct our buildings. Number 4 is cost effective because the length of the work will be reduced significantly. And at the end, the final, it's like the structural flexibility. So if you plan something in this scale, anything need to be changed. The structure, the CLT could be easily changed, because we can easily cut this CLT, and then we can fit these structures as per the field requirement. Thank you very much.
Thank you.
So here is our target to achieve sustainable goal, which is 11. Number 11 is in the study, and here is our reference, and here is our group, the acknowledgement, and this is thank you very much.
Thank you so much.